Welcome to Mastering Basic Graphs in EViews, From Data to Insight, a practical guide designed for students and researchers. This presentation emphasizes that visualization is the critical first step in truly understanding the story your data is trying to tell. As the quote on the right reminds us, visualization is the first step in understanding the story your data is trying to tell. Today, we will explore various graph types, like time series, regression fits, and multivariate interactions, all made possible with EViews. This material has been prepared by the Econometrics group Vietlod, based on the EViews 13-14 user guides, and will equip you with the skills to transform raw data into meaningful insights. This slide introduces the core challenge we often face, the data visualization gap. On the left, we see a raw data table, aptly called the data rectangle. While it holds all the information, it's abstract and difficult to interpret directly. Next to it, we have the noise, a poorly configured graph that, instead of clarifying, further obscures the truth. This illustrates our problem. Raw numbers are inherently abstract, and even graphs can be misleading if not done correctly. Our goal, therefore, is to develop structured methods to effectively extract meaningful signal from all this noise. This brings us to the visual imperative on the right. It highlights two crucial points. First, raw numerical output is simply insufficient for deep analysis. Second, and perhaps most importantly, visualization isn't just about making things look pretty for a presentation. It's a fundamental step in the analytical process, serving as a powerful visual hypothesis test. The most important rule is that data structure dictates graph form. The first question you must ask is, what kind of data do I have? For time series data, you'll focus on trends using line and symbol or area band graphs. For cross-sectional data, the focus is on comparison, using scatter, bar, or XY line plots. For panel data, you'll examine structure, using stacked lines for small n or aggregated means for large N. Finally, for understanding the distribution of a single variable, you'll focus on normality, using histograms and box plots. Remember, identify your data frequency, daily, monthly, panel, before selecting a graph type. A graph view is a dynamic, temporary window. It's linked to your data, so if the data changes, the graph updates automatically. This makes it perfect for quick exploration. When you freeze a graph view, you create a graph object. This is a static snapshot, completely disconnected from the original data. The golden rule is simple. View is for exploration. Object is for presentation. Objects are customizable, savable, and what you will use in your final reports. A pro tip is to always freeze your graph view into an object before you spend a lot of time on detailed customization. This prevents losing your work if you accidentally close the view window. A time series plot of a variable y over time t is our primary tool for visualizing stochastic processes. It helps us identify trends, seasonality, and structural breaks. A distribution plot, like a histogram or a kernel density, is a visual check for normality. It's the graphical equivalent of a Jark-Barra test. A scatter plot of x versus y is the visual precursor to an OLS regression. It allows you to see the relationship, represented by the coefficient beta in the equation y equals alpha plus beta times x, before you even run the regression. Beyond these specific graph types, an important insight in visual econometrics is that a graph is a visual hypothesis test in itself. Moreover, a scatter plot specifically allows you to visually see the regression coefficient before you formally estimate it, providing immediate intuition about the relationship between variables. This slide outlines essential assumptions and conditions, acting as a pre-flight checklist before creating graphs. First, we need to consider continuity. How does your data handle missing values, or NAs? EViews typically breaks the line by default when NAs are present, which can sometimes be misleading. Second, we examine frequency. Are you attempting to plot data with different frequencies, such as monthly and quarterly data, on the same graph? This requires specific mixed frequency graphing approaches for accurate representation. Third, assess the scale of your variables. If you're plotting variables with vastly different magnitudes, such as GDP in billions alongside an interest rate in percentages, one variable's line might appear flat and uninformative. In such cases, using dual axes can effectively display both. As a pre-flight checklist, always remember to check for NAs, gaps in your data, check for outliers that might skew your visualization, and ensure units are comparable or use dual axes when they are not. This slide addresses the challenge of visualizing panel data, often referred to as the hairball. Trying to plot many individual series, like 50 countries, on a single line graph results in an unreadable mess. The strategy for managing this complexity depends on the n size, or the number of cross-sections. For a small n, you can use combined cross-sections to show each individual line. However, for a large n, the best approach is aggregation. Instead of plotting every single line, you should use the mean or median of the panel to show the central tendency over time. A useful tip for large n panels is to not plot every individual line. Instead, use the mean plus standard deviation bounds to clearly illustrate the general movement and dispersion of the entire panel. The primary method for exploration starts from an open series or group window. You simply navigate to View, Graph. This creates a dynamic graph view. If you want to create a permanent graph object from the start, you can use proc make graph. This immediately creates a savable object. For very quick, ad hoc graphing without even opening a series first, you can use the quick Graph menu from the main EViews toolbar. A key takeaway is that most graphing starts with the View button on a series or group window. As a useful shortcut, you can double-click an existing graph to reopen the Options dialog for further customization. The Graph Options dialog is the control center for all your graph customizations. You can access it by double-clicking a graph. On the left, you select the general graph type, such as line, bar, or scatter. In the middle, you control the specifics for that graph type. For a line graph, this is where you change the color, pattern, and symbols. On the right, you manage details, which often relate to multiple series or panel data options. A key insight is that the available options change depending on the object you are graphing. A group of series will have different options than a single series. Within the graph options, you can change key attributes like line color, pattern, dashed versus solid, and line width. For even faster changes, EViews allows direct editing. You can simply double-click on a specific graph element, like an axis or the legend, to open a dialog box just for that element. The most powerful feature for consistency is templates. You can customize a graph to a specific style, for example, a black and white APA formatted style for a journal, and then save it as a template. This template can then be applied to any future graph with a single click. This pro tip ensures all your graphs maintain a consistent look, which is essential for professional research papers. Our first case study involves visualizing a single time series, U.S. Treasury yields. The goal is to analyze its trend over time. The method is straightforward. Open the series TB03MTH, click View, Graph, and select the line and symbol type. When observing the resulting graph, we look for key features, long-term trends, periods of high or low volatility, known as volatility clustering, and any sharp changes that might indicate structural breaks in the data line. In the graph of 3-month Treasury yields, we can clearly see a rising trend from the 1940s to the early 1980s, followed by a period of extremely high volatility around 1980, and then a general downward trend. This visual analysis provides crucial context for any time series model. Here, our objective is to compare multiple economic variables, such as GDP, investment, and consumption. First, we select all the series, right-click, and open them as a group. Then we select View, Graph. We have a crucial choice. A single graph is best for comparing the levels of variables, but only if their units and scales are similar. If the scales differ significantly, we must use multiple graphs in separate panes. This is better for comparing their trends and patterns of movement, as each series gets its own y-axis. If you plot GDP in trillions and the inflation rate in percent on a single graph, the inflation line will be flat. The correct approach is to use multiple graphs, so you can see how the trend in GDP compares to the trend in inflation, each on its own appropriate scale. While line graphs are great for tracking variables over time, we need a different tool to examine the relationship between variables.
The objective of a scatter plot is to visualize the relationship between two variables. Let's call them x and y. The process involves opening the two variables as a group, selecting View, Graph, and choosing Scatter as the graph type. Scatter plots are incredibly insightful, as they can immediately reveal if a relationship is linear, nonlinear, or non-existent. A key feature is the ability to add a regression line, or fit line. This provides an instant visual check of the OLS regression, allowing you to see the estimated relationship and how well the line fits the data points.
This slide presents Case Study 4, focusing on visualizing panel data, particularly addressing the hairball problem, where too many lines make a graph unreadable. The solution demonstrated here is to use combined cross-sections. To achieve this, you would first open the panel series. Next, click View, and then Graph. Finally, from the panel options, you select Combined Cross-Sections. This strategy is ideal for a small number of cross-sections, or a small n, allowing you to clearly see each individual series, as illustrated by the distinct graphs for CAF and CAN. For a large N panel, where plotting every individual series would still result in a cluttered graph, the recommended strategy is to plot the mean or median of the group over time. This provides a clear aggregated view of the overall trend within the panel data.
This slide, Case Study 5, focuses on diagnostics and histograms, specifically addressing the scenario of checking residual normality after running a regression. To perform this diagnostic, you first run your regression to create an equation object. Next, you navigate to View, Residual Diagnostics, Histogram, Normality Test. The crucial step is the interpretation of the results. If the p-value from the Jark-Barra test is less than 0.05, it indicates that the residuals are not normally distributed, which is a violation of a key OLS assumption. This highlights a critical diagnostic concept. Graphs are not merely for displaying input data. They are essential tools for validating your model results through residual analysis. In this example, the histogram of residuals with the normal curve overlaid and the Jark-Barra probability of 0.066 suggests that the residuals are normally distributed, as 0.066 is greater than 0.05.
While the GUI, graphical user interface, is excellent for exploration and learning, syntax is superior for automation and replication. For a simple line graph of a variable x, the command is plot x. To create a scatter plot of x and y, the command is scatxy. To freeze a graph into an object, you use the freeze command, like freeze my graph x.line. Using syntax and scripts is essential for research that needs to be replicable by others. Instead of clicking through 5 menus to create a scatter plot of investment versus GDP, you can simply type scat GDP invest into the command window. This is much faster, especially if you need to create many similar graphs. We've covered a lot of ground, from the principles of visualization